Well, it's close enough. I just did some quick math.
It has to be 2, so you round up.
Okay, so the problem is, I know some of you guys are having problems with the whole setup. I've been working on this new way. I was with some chemistry teachers over the summer, and we were discussing stoichiometry and how everybody has problems with stoichiometry, and somebody had mentioned, oh, there's this way that we've been doing it, and the kids seem to do better at it. Which I really like it once I started working it this way, because it brings more into how we work things in AP chemistry. So, and it's a lot easier. So with that being said, if you have questions and you still are confused, please come see me during tutorials, and I can teach you that other way. Or maybe I will try to make a video and put that up. But I will not be here this afternoon. So keep that in mind. I'm going to talk about limiting reactants today. So I'm going to give you the definition of a limiting reactant. We've already kind of talked about those when we did the nuts and bolts thing. And then I'm going to give you 2 methods to solve for a limiting reactant. I'm going to give you method 1, which all of your friends in on-level and probably Coach Curtis and Ms. Shelburn's class use. And then we're going to do method 2, which is the way I like to do it. And I think it's easier. So you can choose whichever way you want to after we do it both ways. I don't care which way you do it. So here we have this problem. It says we have 45 grams of glucose, and I want to know how many grams of carbon dioxide are made. It's a grams to grams problem. So that means I need molar mass for both of those substances. So the molar mass for sugar, if you remember from the other day, was 180.18 grams per 1 mole. And for carbon dioxide, it is 44 grams per 1 mole. So I'm going to start with what we know. We know that we have 45 grams of glucose. The unit, grams of glucose, is the only thing that goes down to the next area, grams of glucose, and I've got to find a number for that, and I get that from the molar mass, and the number that is with grams is 180.18, and that is with 1 mole. Mole of glucose is on top, and I need to get rid of moles of glucose. So to get rid of moles of glucose, I need to use the mole ratio. And the ratio is 6 moles of carbon dioxide for every 1 mole of glucose. And now I need to get rid of moles of carbon dioxide. So 1 mole of carbon dioxide, there are 44 grams. It's kind of got smaller and smaller as I went across. So then what we do is we multiply in the calculator 45 times 1 times 6 times 44. Close your parentheses, divided sign, open parentheses, 180.8 times 1 times 1. And you should get 66. If we go to 3 sig fig, 66.1, I guess, grams of carbon dioxide. Questions?
Wait, why'd you add the 1?
Oh, because of sig figs, it's 3 significant figures. But it might have been 66.0, just depends. 45, yes. So the next thing is what we call this thing right here is a theoretical, and I'll talk more about this tomorrow, theoretical yield. So if I go into the lab Or say, I used to do research and work for a researcher, and he would say, hey, go make this. And theoretically, if I go into the lab and I take glucose and convert it into carbon dioxide and water, theoretically, if everything goes perfectly and all the conditions are right and the weather's not doing something crazy or whatever, I should get 66.1 grams. If I get more than that, I've contaminated it. If I get less than that, then I've done something wrong somewhere or I've lost something. So, and there's either side, we're going to calculate tomorrow how good your yield is. But if your yield is less than like 90%, you can lose your job. Okay? So these things are expensive, and we want to make sure that we're getting the most out of it than we can. So, yes.
So if we don't, so if it's not, so if the question on the test is 3 6 figs, the answer has to be 3 6. Okay.
Yeah. Okay. So now let's talk about the limiting reactants. So a limiting reactant, I know it's going to come at you, and it's going to be a lot today. When I get to the method 2, it might seem a little bit not as daunting. But what a limiting reactant is, and I'm going to go through some slides. A lot of these are just visuals. Is here I have, for every 1 car body, I need plus 4 tires gives me a car. So if I have 8 car bodies and 48 tires, how many cars can I make? What's the maximum amount of cars I can make? 8. Okay? So what limits me and how many cars we can make are the car bodies. What is left over, or what we call excess, is the tires. So you'll see me today, I'll say a lot of limiting reactant. I'll just say LR. If something is left over, that is called my excess. And I just say excess. So don't let those abbreviations confuse you. Again, here, carbon plus hydrogen gets me methane. So how many methanes can be made with 8 carbons and 24 hydrogen molecules? And we end up looking for these two, these two, these two, so we end up with 16 molecules, or 16 hydrogen atoms left, which is 8 molecules. So, limiting excess. Everything that we've been calculating, remember I was talking about theoretical yield, every time we calculate something, that's a theoretical yield. The only time you're ever going to get an actual yield is if I tell you this is what you got in the lab, or you went into the lab and got it yourself. Everything else we calculate in here is theoretical. So again, here is just what that should look like if we got everything out of the reaction that we wanted to. But sometimes that doesn't happen. Sometimes we have things that are left over. These things that are left over, they're not part of the reaction. They're just left over. Okay? So remember question number 12 in the test where I told you guys the answer was J? And some of you guys were like, that was so easy. Why did you tell me the answer was J? That answer's not J. We told you it's J, but the answer was actually something else because it kind of takes into this account what was going on here. Okay? So if I were to look at this, I would know, or I were to take the problem into account, I would see that these two are excess, nothing's happening with them, so that means that they're not part of my equation. So again, real world, just looking at ideally what it should look like, and then what it happens in the lab. All right, so your limiting reactant is the one that is used up in the reaction. It is all used up. So it is going to be used up first. And when it's depleted, when it's gone, the reaction is going to stop. We're not going to have any more reaction. There's no more when the reactants is gone, so it's going to stop. It determines how much product can be made. So it determines the amount of product, and this, again, like I said, is our theoretical. Theoretically, how much can we go make? Excess, we add it in there. So our limiting is usually the more expensive compound. And what we do is we add excess of something, which is usually cheaper, so that we get the most that we can out of that compound. We want to get more bang for our buck, so we're going to use as little as we need to by making sure there's something else excess in there. So our excess is what is left over. So in these problems, I can ask 4 things from you. I can ask you, what is your limiting reactant? What is your excess reactant? I can ask you your product. How much product can you make? And then I can ask you, since all of your limiting will be used up, I can ask you how much of your excess remains. Okay?
So how does that relate to a chemical equation? Like, you're showing us examples and not like colors.
It's fixing to come into play. Any questions on this? So basically what we're doing is the same thing we've been doing, except for we're talking about limiting and excess reactants. Limiting reactant. Excess is my excess reactant. Any other questions? So we're going to method 1. I'm going to be yelling out numbers, and you sit there and calculate them for me. Some of these I've calculated. This will be the 4th time today. I know some of the numbers, the masses by heart right now, but the answers I don't know. The masses to stuff I know, but not the answers. All right, so method number 1 is exactly what we've been doing. So what you're going to do is you're going to start out with a balanced equation. So this is the equation. I'm going to write this equation. I'm going to talk for a few minutes, and then I'm going to go to the next slide and actually work it out. So if we have this equation, 4 aluminum plus 3 O2, and it gives me 2 Al2O3s. So there's our equation. So what your problem will say is, if you are given, so you go into the lab, and I say, hey, go make this aluminum oxide, and I give you some stuff. And you go in there, and you're going to see that I gave you, say, 100 grams of aluminum. And I gave you 100 grams of oxygen. So what your next goal is to do is to see what is going to run out first. Who's going to limit this reaction? So what we're going to do is you need to stoich it out. You need to stoich it out from one of your givens to your product.
Is it like that thing we did with the...
Mm-hmm. Yes. So that will give you your one answer. Yes.
Why don't you just be able to say something? Like
Nope.
100 grams at the end?
Nope. So we'll stoich it to here, and then you can stoich it to there. So you're going to do 2 stoich conversions. You're going to go from one reactant to the product, the other reactant to the product. Now you'll find What if they give you two products and they don't tell you which product to go to? So if we had something over here and I asked you what limits this reaction and I don't tell you which product I care about, choose one. Just make sure you stoik it to the same problem same product each time. Now if water is present over here, I automatically choose water. It's just because water is easy. We all know the mass of water by now, yes? 18 grams. So that's why if water is there, I choose water because I don't have to calculate its mass. Okay. Once we get our answers, the smallest answer is going to be our limiting, and it's going to tell me my theoretical yield. Okay? So let's go do a problem. Do this problem, actually. So here we go. I'm going to rewrite it. We have 4Al plus 3O2, and that is 2Al2O3. So that's our reaction. You're going into the lab. I've given you 100 grams of aluminum, and I've given you 100 grams of oxygen. My question is, what is your limiting reactant? What is your excess reactant? And what is your, I want to say TY, your theoretical yield? How much product can be made?
Wait, why is it XS or XA?
Excess.
Oh.
So this is where the tedious part comes. You've got to go, I've got aluminum here, and I have oxygen here. And I'm going to stoik aluminum to aluminum oxide. So I have 100 grams of aluminum. I need the molar mass of aluminum, which is 27 grams of aluminum for every 1 mole. Now, where's our next step? The mole ratio, unknown, is 2/4. And then we go to the molar mass. And the molar mass for every 1 mole of Al2O3 is 102 grams. So somebody do that math for me. Now, when I go to oxygen, I do the same thing, except for I'm replacing aluminum and aluminum's information with oxygen, and oxygen's information. So it's the same setup. So I have 100 grams, O2, 188.88, so 189 grams. We have 32 grams of O2 here. 1 mole. We need the mole ratio, and the ratio is 2/3. And the mass of aluminum oxide again. So somebody get that number for me. What? 213 grams. Which one is the smallest one? Aluminum. So that's my theoretical yield. So that's my amount of product. So our limiting reactant is aluminum, while my excess is oxygen. Oh, that should say excess.
So when they ask us on the test, it's only going to be asking for the limiting reactant excess.
Now I might say, hey, how much of that excess of oxygen is left over?
Ooh.
So how many grams did we come in with?
100.
No, total. 200 grams we came in total. How much aluminum oxide did we make? 189. So how much oxygen is left over? 11. Okay?
So you take the total mass minus
The theoretical.
product.
Okay? So now that let's talk about method 2. Method 2. This is the one I like. 1, you starting out with the balance equation, like we always do. Next is underneath that balance equation, write what we're given, like we've been doing. After that, what you've been given, if you've been given moles, then this step doesn't matter because you're already in moles. If you're in grams, then this step we need to do, and to do that, we just divide by molar mass. Once you've done that, you've gotten that answer, you've gotten your reactants in moles, we're going to take each one and divide it by its coefficient. And once we do that, we have our limiting reactant. Okay? So I think this is a lot easier because once I find, if I'm just looking for my limiting reactant, I can do this, bang, I'm done. Where if you do it the other way, you have to do all that math to get to where you want to go. And then when you do that, when it says what's the mass that can be made, you just go back to your moles that you found up here in this step and do your stoichiometry there. Okay? Ready to go?
Yes.
Yes.
That you think method 2 is easier?
It's the way I do it in AP Chem.
Do you make them do it that way, or can they just...
They can do it the other way, but when you're when you're like set for time and then... And like I said, the other way that I've been looking at for the last couple of days, I really like that, and I think that's why I'm going to teach it next year. Just because it reflects a lot on AP Chem.
I signed up for it next year.
He just loves me that much.
No, but
Yeah.
like, for right now.
All right, we good?
And 6 is very good for not taking notes.
Huh? Yes. Okay, here we go. You good? Yes.
Like, you have like a 98.
Start trying.
All right, let's go do method 2. All right, we're going back to our same equation. 4AL plus 3O2 gives me 2Al2O3. Like I said, you're going into the lab. I'm giving you 100 grams of each reactant. So we write down what we're given underneath our reactant. Now our second step, or our third step said to convert whatever we're given into moles. So that means I need to divide each one by its molar mass. So somebody do this for me. 27 grams per mole here, and then here is 32 grams per mole. What? 3.125 over here.
And then the 27 is right there.
3.7? Okay, thank you. 3.70. Most of you will stop right here because that's not the answer, because you got to moles, but we have that one next step that says we have to divide each one by its coefficient. So we're going to divide this one by 4. And we're going to divide this one by 3.
Why do people teach it like other ways? This is a lot easier.
Oh my god. You're telling me that is the same amount as doing all of that?
So go next. Give me those numbers. 1.21 is it for this one?
I
1.325 for which one? Hold on. Is 1 point what? 4? That? Okay. All right. So who limits us? Which one's running out? Oxygen limits us.
I understand it now.
Is it?
It's the first day.
It wasn't the last one. Oh wait, no, the last one.
It was aluminum. So somebody do redo that math for me.
I didn't get that worksheet for it.
You guys,
32.
1.04. I got my numbers backwards.
The second one's 1.04.
Oh, 0.925. Yes. Sorry, I had the other problem in my head.
Yeah, it tripped me out. I was like,
All right. So y'all gotta tell me. Call me out. So which one?
Dang, this one was like a
0.925. All right. So going back to our correct answers, what is our limiting reactant? Aluminum is my limiting reactant. That-
Can we do this for the other ones too?
That's what I'm trying to work. I'm wanting to make sure that I got the steps fully done. That means my excess is oxygen. Now we're not done because our problem says what's the maximum amount of product that can be made. So we go to our limiting reactant, aluminum. We go to all that math we just did, and we go and we find the moles that we calculated. And now we stoich from here to grams of this. So we have 3.70 moles of aluminum. We have the ratio of 2/4. And we have 102 grams over 1. Somebody do that math for me. A 102, yes.
So you do the unknowns and stuff before them.
What'd you get, 189? Rounded, it's 189. So 189 grams of Al2O3. Does that match what we got before?
Yes.
Yes. Which one do you like better?
This one.
I like that.
I feel like we've done the first one before.
yeah, and I just learned
It's okay. I didn't understand the first way, so I can't
Yeah, I didn't.
say that. Yeah, I still don't really understand it, but
Okay, so let's go do some practice.
How do you different, like,
What do you mean?
like, AL2 over AL?
You got to look here. If this is AL, it's always unknown over known. So if this is AL, moles of AL, then down here is moles of AL. Yes. Yes. Okay, let's go. Here is our problem. I'm doing method 2. If you want to do method 1, then you're more than welcome to. But I am working on method 2. So I'm going to rewrite my equation. This is why I always tell you to write that equation so we can work under it, because that method that we just worked does a lot of underneath the problem. So what are we given? I know that we have 10 moles of H2 and we have 6 moles of O2. And this question is really simple. It just says, what's your limiting? What's your excess? So method 1, or method 2, we've done step 1, we've done step 2. Step 3, convert to moles. Do we need to do step 3? No. Go to step 4. Step 4 says to divide by coefficient. Which one limits us? Hydrogen is our limiting reactant. Our excess is oxygen. And that's it. If you were to do it the other way, you kind of have to go a little bit further. You'd have to do a little bit more math.
Wait, what about the yield?
The what? Yield. Okay, so if it says, what is the amount of water that can be made? So if we go further and says, what's the amount of water that can be made? Then we go back to our amount of moles. And we stoich that to water. So 10 moles of H2. And for every 2 moles of H2O, we get 1 mole of H2. So we can get 10 moles of H2O. And if it says grams, then we just multiply that by 18.01 and say 180.01 grams. Huh? What, the mole ratio?
10 times 2 is 20.
Oh, 20. Oh, sorry, that should be 2 H2. There. Okay. Let's go do another one where it does the multiple steps. All right, so here's our reaction. It says you are given 79.1 grams of zinc, and you have 82.0 grams of HCl. So all those problems we've been talking about, remember, if you look, it'll say with excess of whatever. That means you've been doing that. We just haven't been looking at that. I haven't given you some numbers. I haven't said go find what the excess and limiting is. That's what this is right here. So my first step is we're in grams. So we need to divide each one by its respective molar mass. So zinc is 65.39. Somebody get that math for me. And hydrochloric acid is 36.5. Somebody get that for me.
The second one is 2.24.
There's my 1.21. Okay, so are we done? No, what's the next step? Divide by coefficient. So this gets divided by 1, so I get 1.21. This gets divided by 2, and that gets me 1.12. All right, so what limits us? HCl. So HCl is my limiting, and zinc is my excess. The next part of the question says how many grams of hydrogen can be formed? So now what we need to do is we need to take our limiting reactant and we need to stoich it to hydrogen gas. Well, we're already in moles right here. So that's the number I'm going to start at. So 2.24 moles of HCl, and for every 2 moles of HCl, it's 1 mole of H2, and the molar mass of H2 is 2.02. So somebody do that math for me. Two point something. .25 grams of H2. And that's how much can be made. So your homework tonight is 20 through 23.
So on the other ones, like